Once I have my state machine created, the next step is to create an avoid function. To start out, I'm going to use the keyword void because this function will not return a result as the state function did right here. And I'm going to name it avoid because it's going to avoid obstacles. It's going to have one argument, and that argument will be the event that is generated by the state machine right here. I'm declaring it as a byte because the largest number the event can be at this point in time is the number 7. 1 plus 2 plus 4 makes 7. So a byte will definitely be able to handle that. And I would also like you to remember that the event variable up here is not it's not the same variable that's down here. We actually have to link those two things in order to pass this information that's generated by the state machine into this avoid routine or this avoid function that we're creating right now. To the main part or the central part of this avoid function is a switch control structure. We're going to feed the event into this switch. The way a switch works is it's kind of like an if statement, except that we declare a series of things that can happen based on what the event is. So we can have case 1. That's when the event turns out to be the number 1. And the way our robot's programmed and built right now, that would mean that the front sensor is triggered. If that happens, then we want our robot to turn fairly sharp one way or the other because it's heading into a wall or something. So I'm going to say motors.turn, and I'm not too particular at this time. I'm just going to use left because that's as good as right. And I'm going to say 90 degrees. That's a pretty sharp turn. My robot's headed for disaster, and now I'm averting it. After that happens, I'm going to type brake, and that will get me out of the switch control structure. Now it's time to define another possible case, and that would be the case 2 when the left sensor is triggered, in which case I want my robot to turn right. I want to get away from whatever's on the left. Oh, and I'm only going to turn 45 degrees. I don't need to turn that much because if it's showing up on my left side, I'm probably not heading straight towards it. And then to get out of this case, I'm going to use brake. And then the last case that that's likely to occur is case 4, when something happens on the right side of my robot. So my right sensor is triggered. And what I want to do then is turn left. And again, I'm only going to turn 45 degrees because I'm probably not heading straight towards it. So that's probably enough to keep me from bumping into it. And then to get out of this case, I'm going to use the brake command. And then the default, if nothing is triggered, if none of these happen, or if the event is 0, then what I would like to do, default, is just drive forward. So I'm going to say motors.forward. And then to get out of this situation, I'm going to use brake. And now I have to close my switch structure. And I'm going to go ahead and get all my white space correct here, which I had already. And then I have to make one more change to my program. Right now, my program just prints whatever my state machine is generating right up here in the loop. It prints the state. Instead of printing the state, I want to avoid this state or react to this state. And so what I'm going to do is use the avoid function. So what happens is this state function is called and generates some sort of event. It looks at all of the sensors, comes up with a number that defines that event. And then that event is fed into the avoid function where it's used. This is how we're linking the information that's generated right here by the state function and feeding it into the avoid function as an argument. Here it's passed into the switch control structure where we can see if it's event 1, event 2, or event 4, we react accordingly. So I'm going to go ahead and give this a try and we'll see how it works. While this program does result in a robot that generally avoids obstacles, you'll notice right off the bat one of the annoying bugs is it registers a ton of false positives. You'll also notice that as this robot's traveling the maze, it tends to get in a little bit of a rut. It's always going in a circle because it always turns left whenever the front sensor registers is triggered. And so what would be nice is to create a robot that behaves a little bit less predictably.